Welcome back again and welcome to virology. Here in this video, I would like to discuss about viral structure, especially spherical virus, and how to calculate triangulation number of a spherical virus. And from the triangulation number, how you can calculate how many protein subunits are there. One of the most important component of virus is capsid. It not only protects the virus nucleic acid from the external environment but also helps in host recognition, attachment, maturation and release. Capsid is made of protein subunits called capsomer, but due to the small size of the genome, virus generally encode one or sometimes more than one types of protein in large amounts and arrange them in head-to-tail fashion like this to form a symmetrical structure like this. If 6 such structure arrange in this way, a regular hexagon will form. This structure is energetically favorable. That means it requires less energy to stabilize the structure. But hexagon is a flat or planar structure. If virus arrange subunits in this way, an enclosed structure will never form. So, if one triangle is removed and the two free ends are joined, then it will become like this, or a 3D or an enclosed structure will formed. If this structure is placed at the top and at the bottom and in the middle portion is filled with 10 such triangles, an enclosed structure will formed. This is called icosahedral structure. Most of the virus assume this type of structure or more or less similar structure like this. You can see in icosahedron there are 5 plus 5 plus 10. That means 20 triangular faces, 10 such pentamers or vertices. It has 12 five-fold symmetry through 12 vertex. It has 10 threefold symmetry through 20 triangular faces and 15 twofold symmetry through the 30 edges. When the size of the viral nucleic acid is comparatively large, it requires more space. So they form this or this type of structure. Now moving to the next topic, triangulation number or T number. It is calculated using this equation. It tells us the size and complexity of the virus. For example, T1 and T3 virus. Here, T3 is larger than the T1 virus and it is more complex than T1 also. In this equation, h and k are any positive integers including 0. But how you will know the value of h and k? Here is the solution. Imagine the hexagonal structure is a part of the large net, and if we transformed at least 12 such hexagon into pentagon, icosahedral structure will formed. The h and k tells you the distance between the two such pentamers or the five-fold symmetry, or how many jump is required to reach the next pentagon from one pentagon. Let's see how. Here is our original hexagon that is converted into pentagon. I have drawn a triangle in such way that its three corners touched the three neighboring pentagon. Now draw h and k vector. In this case, h is 1 and k is 1. In this case, h is 2 and k is 0. And in this case, h is 2 and k is 1. And in this case, h is 3 and k is 1. In this way, you have to calculate the value of h and k and then put the value of h and k in this equation to get the triangulation number. For example, if h is 1 and k is 1, then T number is 3. Now move to the next topic. In icosahedral structure, there are 20 triangular faces. and in each triangle there are 3 protein subunits. So in total 20 multiplied by 3, that is 60 subunits are there. Or you can calculate the number of subunits using this equation when the T number is known. So in T3 virus 60 multiplied by 3 or 180 subunits are there. This concept is called quasi-equivalent structure and was developed by these two scientists. So that's all for now. If you want to watch more videos like this, then don't forget to press the subscribe button and press the bell icon. You can like, share and make comments, and thanks for watching.